this page you will see a summary of what we know so far of parabolas, and in this video we will concentrate on the domain and range of the parabolas. Look at the standard form again. We know this y equal to ax squared plus bx plus c by heart now, but we can also add this one, y equal to a x minus x1 and x minus x2, product of that, where this x1 and x2 represents the x-intercepts of the parabola. We can also write the equation standard form in this form, y equal to a bracket x minus b squared plus q, and pq here are special values because they show us the turning point of the parabola. So at P we will find the minimum or the maximum of Q, and in all these cases we may not have a equal to 0 because then we not have a quadratic equation anymore. Then we also must note that x equal to minus b over 2a gives us the axis of symmetry. If we complete the square for y equal to ax squared plus bx plus c, then we get that x equal to minus b over 2a gives us the axis of symmetry for the parabola. And the value here, the x value here, also represents the p-value of the turning point PQ. So the q value, we also get that from the completion of the square, but it's most of the times it's easier to just take this value and substitute it into the formula to calculate the value of q. And then just a reminder again, if a is positive, the parabola is concave up, and when a is negative, the parabola is concave down. If we look at the green graph, which is labeled F, then if we want to find the domain, we see that we can have any value for x. So our domain will be all the real numbers. But if I look at the range, and the W is just from Afrikaans we say waarde versameling, so the W, the range here will be all the y values. So if I have a horizontal line moving upwards here, the first time that I touch the graph is here at -1. We can label it the point F, which is 0, -1. For the range, we will start with the y value at F, which is -1, and then continue up until plus infinity. And we can never have a square bracket at plus infinity. We can now write the equation for this green graph by writing it as, this is f, which is equal to a x minus the p-value square plus the q value, because we want to write it in the form y equal to a x minus p squared plus q. That is what we want to do. So what is our pq value? Our pq value is actually here at f. This is also our pq value, which is 0, -1. So if I plug it in here, I will get a y equal to x minus 0 plus -1. So if I simplify it, I get x squared -1, which is just ax squared -1. So this is my y. And since I know that f lies, that's a turning point, but I need another point, I know that d -2, 1 lies on f. That means I can substitute x equal to -2 and y equal to 1 into this equation. So I get 1 is equal to a times minus 2 square minus 1. That will give me 4a is equal to 2, so therefore a is equal to half. If I plug that back into my formula, then I will have a formula for f of x, which is a half x squared minus 1, and I don't need a bracket there, I can just write x squared minus 1. So in fact, it was just the regular mother graph stretched horizontally and then shifted one down. Let us look at the red graph. We see that the red graph, we can put arrows here. First of all, let us look at the domain. What is the domain? Domain will be all the x values, so all the real numbers. But the range will be everything from 0 downwards. So we will start at negative infinity, then we'll continue to 0, and we will close the bracket there for 0 because it's included. So everything less than or equal to 0 will be in the range of the function q. We can now again use this formula y equal to ax minus p squared plus q, and I can put it in here. X, first of all, my pq here is at a, and that is x is minus 1 and y is 0. So I can say minus 1 square plus 0. And I just do it like this to remind you that we are using the formula like here, because it helps us with the shifting, horizontal shifting. So y is equal to a x plus 1 square, and there's no q value. We also know that the point f here, which is the point 0 minus 1, so if 0 minus 1 lies on q. Therefore, I can substitute it into this equation here. I will have minus 1 equal to a, x is 0, plus 1 square. So in this case, I will have a equal to negative 1. If I plug all my values back into number 1, into that equation there, then I get q of x is equal to minus x plus 1 square. So in fact, this is just a regular y equal to minus x square that was shifted 1 unit to the left, because here we had x minus 1. So our p is equal to minus 1. It's less than 0, so q is y equal to minus x squared shifted 1 unit to the left. That's all. If I look at R now, which is the blue graph, that's actually a parabola that was rotated 90 degrees, but if we rotate the whole parabola, then we don't have a function anymore, so we don't use the bottom part here, and that gives us that function r of x. So first of all, when can I calculate the square root? I must make sure that the inside must be greater or equal to 0. So x must be greater or equal to negative 1. So the domain will be everything from negative 1 up to infinity, because you can see the blue graph goes on here to infinity. It doesn't grow as fast as a regular parabola, but it also slowly goes to infinity. If I look at the range, then the smallest value that I have is 0, 0. but 0 is included, and from there onwards it will also go to infinity. So that is my range. I don't have anything more to write here. So in effect, I can also say it is the f of x equal to x squared rotated in 90-degree clockwise and shifted 1 unit to the left. But y is greater or equal to 0, so we do not take the bottom part. If we want to do a description of r, that will be close.